Welcome everyone to the lecture again today. So as Jason said, we'll be talking about cost-benefit analysis with LEAP. And cost-benefit, we'll actually also have an exercise where we'll assign two exercises today, one of which will be about cost-benefit analysis. And to get you started on that, I just want to take you through both the LEAP interface as well as just the general concepts surrounding cost-benefit analysis in LEAP. So you've seen this schematic of LEAP at this point on several occasions before now. And I just want to point you to the integrated cost-benefit analysis box here on the right. That's what we'll be talking about today. You can really do cost modeling for all facets of your LEAP model. So you can do cost modeling on the energy, the non-energy side, the supply, as well as the demand. And as we will be talking about cost-benefit analysis today, we'll really be talking about these two boxes that I just highlighted here. You can monetize particular pollutants that you model regardless of whether they're occurring. And you can also add these to the cost-benefit analysis in the end, which will account for all the costs and benefits incurred throughout your main energy system analysis. So I'll be taking you through different places in the model where costs and benefits can be defined and specified, and explain how LEAP does its overall calculation of the costs and benefits. In LEAP, as I said before, costs can be included in the energy and the non-energy modeling components. Typically, real costs are used, so you don't have to worry about inflation. In principle, you can also model nominal costs, and there is an inflation factor that I'll be showing you later that you can use. LEAP uses a single projected average inflation value, but we generally don't advise you to use that. Instead, we suggest that you use 2020 euros or 2020 US dollars, because adding or using nominal costs and adding this inflation value really just adds an additional complication and often makes it harder to interpret the results. You can also account for social costs. So generally people will do the accounting for social costs. These are costs that are paid by society as a whole, irrespective who pays. But you can also put in costs from the perspective of project developers or industry. But usually people think about the cost-benefit analysis in LEAP as trying to account for the social costs and the total social costs and benefits that are incurred. Costs can be reported both as undiscounted and as discounted costs. And LEAP avoids double counting energy costs by drawing a consistent boundary around the costing analysis. And I'll also be showing you how to do that and what that means. So on the right, on the left side here, in order to do cost modeling in LEAP, you have to enable this costs box for your entire model in the settings. And well, you've seen that box, but I'll show it to you again. And then under costs, you can select a number of options. One, you can define the cost benefit calculation boundary. This is what I just talked about, and we'll have a very detailed slide that will explain to you how and why this boundary is important. You can also tick the environmental externality cost box that will add another branch to your model called effects. And there you can define the monetary costs associated with different pollutants, which can then be included in the cost benefit analysis and will be reported for the scenario that you're looking at, for all the scenarios that you're looking at. There's also a box for foreign exchange fraction of costs, and this will will enable you to assign how much of the costs that are incurred can be attributed to foreign exchange. And then you can also cap what accounting formula LEAP follows to annualize capital costs. Capital costs are financed at the model discount rate, usually, if you select capital recovery factor to default, and then they're incurred over the lifetime of the equipment. You can then also set the discount rate that you're going to be using in the model and an inflation rate. And so the inflation rate will be used if you want to do nominal costs rather than real costs. If you're just going to use 2020 US dollars, for example, then you would just set this to 0. I now will take you through the different sectors of where you can define costs. You can put into the model unit cost. So generally you put into the model unit costs. So you add to the model the costs per unit of equipment or per unit of emissions. And when the model runs, it will calculate the extended cost at runtime based on how much equipment is being deployed, how many emissions are being incurred. When you activate costs, a new variable will appear for demand costs, and it will essentially, which you see here on the right, and it essentially allows you to use 3 types of methods, which I've outlined here. You can specify costs per activity, so this could be costs per vehicle kilometers traveled, costs per ton of emissions emitted. You can also specify total annual costs. So, for example, the total annual costs of a driver education program, or the total annual cost of updating a home or updating homes. And you can also specify the cost, and this is a little bit more complicated, so people usually go with the first 2 options, but you can also specify the costs in terms of saved energy relative to a reference scenario. So, for example, if you want to specify the incremental cost per unit of energy saved due to efficiency and updated building shells, this could be an example, or here below, efficiency retrofits of long-haul trucks. So you could specify the amount that is being saved by implementing this type of retrofitting. Generally, these demand costs exclude fuel costs. Fuel costs are calculated elsewhere on the supply side of the model. So when you specify costs, you would not consider the cost of a specific fuel that is used in an activity, but you really would only specify those costs that are apart from the fuel costs. When you add costs throughout the different modules in your model, you can really get meaningful results if you add costs to all of your equipment. So in some sense, it's important to be consistent. You don't just want to be adding costs to a couple of items, because you end up comparing two unequal things. So it's, when you do a costing analysis, you really want to go through and you want to add costs to all your models or modules in the cases where, in particular in the cases where the costs in a mitigation scenario differ from those that are incurred in the baseline. So that's generally the guiding principle when deciding where you want to add costs.
Charlotte, we've just gotten a question here about the inflation rate and exchange rate. Question is that they might fluctuate from year to year. So how would this be considered in the model?
And I think in the case, and please correct me if I'm wrong, Jason, but in the case of an inflation rate, it would not be. So you would have to calculate an average rate throughout your production years based on the fluctuation that you think is going to take place.
That's right. Yeah, I'm just going to reiterate what you said earlier, Charlotte. We generally advise not using those features. It's really better and simpler to do your cost analysis in LEAP using real costs. So those are constant year costs. You take inflation out of the equation that way. And then we usually advise, you can turn on the option to show the foreign exchange fraction of costs. In that case, you can have the amount of exchange costs vary from year to year. You would do that in your expression for the foreign exchange fraction of the costs. But we often advise people not to use that feature as well because it just adds extra complexity to the model. It doesn't necessarily improve the analysis. You can, if you were not using that feature, all you would do then is just make sure that the costs that you specify in the model are total costs inclusive of any exchange rate costs. And that would result in a model that's a little bit simpler to interpret. If I could just say one other thing too about the specification of costs and where you need to define costs in a scenario. It's of course better if you can have more costs. If you can have costs defined more comprehensively in your model, you'll get more interesting results out of it that way. But it's often the case that there's not time and there may not be data to define all of the costs in a model. And in that case, what can be really useful is to focus on, if you're doing a scenario analysis where you're comparing scenarios, for example, a mitigation analysis where you have a baseline scenario and an emissions mitigation scenario, it can be really useful to just focus on making sure that you specify the cost differences between the scenarios correctly. So that means you look at the places where the scenarios differ and make sure you have costs at those places in your model so that when you compare one scenario to the other, you get a consistent estimate of the differences in costs between the scenarios. And for places where there are no differences between the scenarios, and that will usually be a lot of the model, even in a sophisticated mitigation analysis, you don't need to worry about having costs there because when you do your scenario comparison, the costs should be the same in both scenarios. So that's another way to think about this, really just focusing on places where scenarios differ and trying to make sure you have the costs correct in those cases.
Let me quickly switch to LEAP so we can see what that costing may look like. So I'm in the demand branch here. I'm going down to refrigeration. So at the moment, costs aren't activated. So I would go into settings and I would activate costs. And now I have several new variables that just appeared, in particular demand cost. And so this under the expression field is where I'll be entering my cost. And something that I really want to stress here is that generally LEAP, because of its base annual time step, you will always want to add costs in a per year unit. And so, for example, for refrigeration, you could be adding, there's a very useful function in LEAP that is called annualized cost. So I could be adding, for example, you could imagine that a new refrigerator in the baseline and the existing refrigeration module costs about $500 and you then also give it a lifetime over which that cost is being annualized. I have to fix my spelling. You can't really see it now because the window is too small here, so you could go into the builder and look at the full equation there. So what LEAP will do with this is that it will annualize the cost of $500 over 15 years. When you look at the table, you can see that would mean that the refrigeration module would have the cost of about $33 per year. And since we haven't added costs for the other technologies used in this demand branch, they're just zero. And now if we switch to the baseline scenario, you see that since we haven't changed that value in the future, so we're assuming that these are current dollars and they're staying the same through time, and the cost of a refrigeration module is staying the same over time, these costs are the same throughout the modeled years. The other type of costs that you can quantify in LEAP are energy transformation costs. So these are the costs of delivering electricity. They're the supply side costs. And you can add these in the transformation and the resource branch. In order to add costs to the transformation resource branch, or to the transformation branch in particular, in addition to activating cost for the entire model, you also have to make sure that costs are activated for the particular module that you're looking at. And LEAP will consider these costs as long as they are within the costing boundary, which I will show you how to specify that later. And similar to the way that a new variable was generated in the demand branch when you activated costs, activating cost for a specific module in the transformation branch will result in a number of new variables showing up. And you can then go in and change these variables. And the variables that will appear, and so costs that you can quantify in LEAP, include the ones that I'm showing here on the left side in the list. So these include capital costs, costs for new equipment, or building new infrastructure, and these are amortized during the process using process-specific interest rates over the lifetime of that equipment, that piece of equipment is being used. You can add fixed and variable operation and maintenance costs. You can add costs for retiring equipment, decommissioning costs, and you can also add other industry and module costs. Again, fuel input costs are calculated separately based on costs of other modules and resource costs. And so if we go back into the model, I'm going to go to electricity generation. I'm then going to go into properties. So you do that by just right-clicking onto the module and then going into properties. This will show this little pop-up window that specifies the module that you're in, and then gives you all these options to select. So you do want to make sure that here you have costs turned on. And then in order to change the costs, you would go into the processes, and now you see all these different variables that weren't in the original model, but are in a model where costs are being activated for both the entire model as well as the specific process. And so here you have capital costs, you have fixed operation and maintenance costs, stranded costs, variable operation and maintenance costs. And so you can change these. And then you also have a variable called lifetime. And so this is the lifetime of the equipment. And when you calculate, when you add capital costs, then these will be occurred over the lifetime that is specified here. We also have resource costs in LEAP that you can specify. These include import costs and export benefits. So even in the case of the question earlier during the exercises, you have surplus electricity production and you may export it, then you could have benefits of that. But also if you have a extraction process that you have specified in your model, you could be exporting resources and incur benefits through that. The tracking revenue that you retrieve from exporting resources is optional. Then you have, as I said before, the indigenous cost, the cost of extracting resources from the environment, which are essentially a depletion cost. As you deplete that resource, you incur a cost. And then you have the social cost of, you may have the social cost of unmet requirements for fuel. So in a model where you haven't enabled imports, for example, and your energy production is insufficient to meet demands, you may want to specify costs of unmet demand. Cost of brownouts due to inadequate electricity supply is a good example for that. So I just want to go into resources here. And so you can see again how these variables have been added. You have indigenous costs, export benefits, import costs, and costs of unmet requirements that you can specify. And these are usually, so it's important that you specify what the costs are per. Usually they're in a unit per amount of that energy. There's a number of units that you can choose from. So you could set it to ton. For example, in this case, it's set to per gigajoule of that particular resource.
And notice how some of those units are energy units and some of them are not. There are mass units there for natural gas. You would find volumetric units. This is a nice feature of LEAP. If you have costs that are specified or denominated in some alternate unit, LEAP will do the conversion for you based on the properties of the fuel in the fuels database. So you might know, for example, the price of gas per cubic meter. You could put that in, and LEAP would convert that using the density of gas and the energy content. It would convert that into the effective cost per unit of energy.
So I'm just scrolling through so you can see all the different units that are available in LEAP rather than just the end of the unit options. And this is true for all the different costs and benefits that you can incur here. So then you can also, and I hinted at this initially when I showed you the two boxes over which you can do the cost benefit analysis, you can also monetize non-energy and pollutant cost. So non-energy costs requires enabled costing and doing the non-energy modeling, which you may remember is an option in the settings. And the cost variable here is meant to represent the total costs of annual non-energy emissions. So it's not a per unit of pollutant cost, but it's the total cost of the annual emissions of a pollutant from a source in the non-energy sector. And then you can also cost or monetize environmental externalities such as pollutants, the different pollutants that you modeled in the effects module. And these will be specified per cost, as costs per unit of emissions. So you just have to make sure that you're aware that the way that these are quantified or the unit per which they are quantified is different between those two. Usually, I should add, pollutant emissions are quantified in the environmental externalities, so in the effects module. But there are emissions in the there are types of emissions in the non-energy module that you may want to quantify just as a whole. So for example, for landfill emissions, you could have just a single value overall for the activity. So let's now talk about the costing boundary. I kind of hinted at that a number of times and emphasized it, but then never explained what it really was about. And it's very important, but I just wanted to make sure that we kind of had gone over some of these basic concepts in the cost benefit analysis before getting to this, because I think it makes it just easier to understand. So the default way in which the cost benefit analysis will be carried out in LEAP is for the complete energy system. So this includes the demand costs incurred in the demand branch, The bottom-up costing of all the energy transformation modules for which you have activated the costs and defined them, as well as the resource import, export, and extraction costs. Of course, I mean, that might be obvious. You can only count costs that you've actually added. So just adding the cost function, but not adding actually any costs will not allow you to do a costing for the full model. But Leap, in addition to allowing you to cost the complete energy system, also gives you the option to cost a subset of the energy system. This includes usually the energy demand cost. So it will go, you limit, you essentially move up the boundary starting from the bottom up. So it will always include the energy demand costs, but then you may limit your costing subset to only some of the transformation modules. So for example, you could imagine that you would calculate the costs for transmission and distribution and for electricity generation, but not for any of the refining and processing steps associated with oil refining, coal mining, and charcoal production, as well as not for resource extraction. And the reason you might want to do this is that you don't have data available for these other steps, but also because you may primarily be interested in electrification. And so this is kind of where you set your boundary. If you do decide to only look at the subset of the energy system in your costing analysis, you do have to specify a delivered cost, which is used for fuels produced outside the boundary. Often market prices are used for that. Essentially, you would then think about this in terms of what types of fuel does your, in this case, electricity utility need to receive, and what is the cost of delivering these fuels to your electricity generation module. The non-energy and pollutant costs are not affected by setting this boundary. And so you don't, even if you do use this possibility to limit your costing boundary to a subset of your module, you would still quantify your non-energy and pollutant costs across the entire model. So
Charlotte,
I just want to.
Before we move off of this, there was a question which I think we should take a moment to talk about, which is where are fuel costs considered? And this is it's a little bit of a complicated answer. The answer is it depends on where you're setting this costing boundary. If you set the costing boundary to be the complete energy system, which is the red box here, then what LEAP is doing is it's calculating for energy supply, it's calculating all of the energy supply costs from the bottom up. It's looking at costing within each of the transformation modules. In the resources branch, it takes into account any costs of importing energy, any revenues from exporting energy, any costs associated with extracting primary energy from the natural environment. And so in that sense, then LEAP is calculating the costs of fuels itself. And that's where the fuel costs, that's how the fuel costs are being determined. If you set a more restricted costing boundary, though, then LEAP is only doing that bottom-up costing within the more restricted boundary. That's the green box here. So in this example, LEAP is calculating the cost of electricity on its own based on the production costs that are specified in the electricity generation module and transmission and distribution costs that may be specified in that module. And for the other fuels that get used in those modules or other fuels used in final demands, those costs are going to be determined by a new variable that shows up called delivered cost. And Charlotte will show you that in a second. In that new variable, you get to specify the cost of, essentially the cost of delivering fuels to that point in your energy system, the costs of delivering fuels to the boundary. So then those would be, in that case, then you could have fuel costs calculated in two different ways. You could have some fuel costs still being calculated from the bottom up, but others that are specified in one one single variable called delivered cost. So it does depend on how you set the costing boundary and what type of a model you have set up.
So when we go into settings, we here have set the costs, and then under the cost option in setting, we can specify what this what the costing boundary that we want to use is going to be. And so here you can see there is the option of that is turned on, the complete energy system costing. So this would quantify costs and benefits across your entire model. But you could also set it to only include costs that are set to final, that are included in your final demands, or limit your costs to transmission and distribution. And if you had several more, so I'm going to go out of, so you can see this better. So in this case, our transformation module only has our transformation branch only has two modules. It has transmission and distribution and electricity generation. But if you did have refining, for example, or charcoal processing here, then this drop-down menu would provide you more options that you could select. So you could set it to transmission distribution. It would then also provide you an option that would set the boundary limit to electricity generation, as well as charcoal production, depending on the order that you're using. And so if we do set it to transmission and distribution, you can then see how under the resources branch and each of your particular fuels, you have a new variable showing up that is delivered cost. And so this is where you'd be specifying what that delivered cost is. You would make sure that your units are appropriate. And so these costs here could either be bottom-up costs, so the actual cost of extracting natural gas or coal, or harvesting wood or hydro, but they could also just be the market prices that these fuels cost and that need to be covered when purchasing them in order to transfer them to your electricity generation process. And so when you do the final cost reporting in your results view, so after you've added all these costs and you click on results, your costs and benefits get recalculated within the boundary that you've specified. You can do the cost reporting in real or in discounted costs. You can present them as annual or as cumulative costs. You can look at all or just selected cost types and categories. And you can look at incremental costs of one scenario compared to another. And so here on the right, for example, you can see that there are actually costs. So negative costs mean cost savings for secondary fuel production, and then small cost increases for that are part of variable operation and maintenance costs in your transformation modules, as well as some capital costs, additional capital costs that you see in this scenario. And so this is just highlighting again which options you have. So this is what this plot shows. It shows discounted cumulative costs for just one scenario compared to relative to another.